So choice one on unit 5, a card, and remember, do you guys remember what unit 5 was about? What type of function? There's like three major types we learned in algebra. Okay, good. So keep that in mind when you're doing the questions from unit 5, because exponential functions has a certain formula that we do expect you to remember, although it has been a couple months. Um, You're gonna see it in geometry, algebra 4, so it's a pretty important one. But we have a car that was originally sold for $18,000 with 1/5 of its value each year after it was bought. After 4 years, how much is the car worth? Write an equation for the value of the car, C T years after its release. So I'm gonna start with this one. Because if we can get the equation, then question one is a lot easier. You can also like problem solve your way through question one as well, like without making the equation, but then part two requires the equation. So let's just start there. When we think of exponential functions, what should we automatically think of as far as formula? So like how linear is y equals mx plus v, exponential is how quadratic is y equals ax squared plus bx plus c. Exponential is no, that's quadratic. Okay, well maybe we'll try to problem solve our way through question one and maybe it'll bring up some memories. But it would be a lot easier if you just remembered the formula when we're setting up these problems. Bailey? A times b what? No, this is not it. When we have a variable square, that's a quadratic function. For exponentials, almost like even in the name. Okay, exponent, what about the exponent? Okay, well, let's try problem solving that right here then. Because I'm not gonna tell you the formula. It's something you could look up. With notes on it, you can hold test on this, and it's a pretty good average test. If you know how to use your notes. But anyway, we can problem solve our way through it. What is 1/5 of 18,000? Maybe 20? Is that what we said? No, that's not possible. Right, 18,000 is a big number, 20 is not 1/5 of that. Oh, better? 3,600? And what math did you do to figure that out? You mean 18,000? Yeah. Okay. So you can type this in your calculator and get that 1/5 of 18,000 is 3,600. It's losing 1/5 of its value each year after it's bought. So after 1 year, it's gonna be whatever 18,000 minus 3,600 is. I'm gonna do that off to the side. I hope you can do that type of math in your calculator without me needing to show you that part. All right, so 18,000 is 14,400 is what it's worth after 1 year. So maybe let me make a table. After 1 year, it's worth 14,400. Now that doesn't mean that it's losing 3,600 each year. It's losing whatever a fifth of its current value is. So now its current value is 14,400. We need to figure out what 1/5 of that is. Do that. I get that it's losing 2,880. Now that's not what it's worth after 2 years, that's what it's losing. So then I still have to go back and do 14,400 minus 2,880. There is an easier way to get the answer, but you can forget your formula and you can at least problem solve your way through it. Figure out what a third of that value is, or not a third, a fifth of that value. Which for me, I'm getting 2,304. Running out of room. But it really shouldn't take that much room if you know the formula. I need to subtract that from the 11,520. I get 9,216. But we want it for after 4 years, so I'm going to do it again. So times 1/5. I get 9,316. Okay, I get that that's 1,843.2, but then I need to even like subtract that from my current value. And then I get 7,372.8 after 4 years. That's what it's worth. At least that's what I get from doing it the long way. Earlier in the semester, we took notes, we like discovered this, that yeah, you can find the answer, but it's pretty tedious. It requires a lot of scratch work. It is possible though. What its initial value is always when like your time is 0. So like, don't confuse it either. This is when time is 0. After 1 year, it's worth this much. After 2 years, it's worth this much. 3 years, 4 years, that's the amount it's worth. All right, now did anyone now remember the equation for it? For exponential function, the basic setup. Okay, good. So this is your basic setup for exponential functions. Think of it like your x is the exponent. Exponential, x is the exponent. For quadratic, I mean, those are more recent to you, you know, it's something squared. For linear, and we learned that since middle school, y is mx plus b. For exponentials, it's a times b to the x. We also will express it like this when we have like a percentage or something that it's growing or decaying by, like in this problem. But in these setups, A means the same thing. What does A stand for? Initial amount. What was my initial amount in this? And then B stands for what? It's similar to rate of change, but we don't call it that because then that could be confused with slope. In these, and we probably can't tell what it's doing each time with these values. But let me give you another example of an exponential function. Okay, so I just made a random example. What is the pattern here? Are they adding the same amount each time? All right, no. Are they multiplying the same amount each time? Then that's what makes it exponential. And what you are multiplying by each time is your b. You guys remember what we called that? What word did we use when we talk about multiplying? And we use it in math unit a lot. Don't pull up notes because there's really no hard time on this one problem. Like I promise I taught it to you. Or you can easily look it up. What is b so for and exponential function? They're common factors. So in this random example I made up down here, what would be my common factor? 2. But that's what I'm multiplying by each time. In this, it's not really clear what you're multiplying by each time. I mean, there's ways to figure it out. Like if you take one of the numbers and divide it by its previous number, so like I'll take 11,520 divided by 14,400. I get 0.8. So that could be my common factor is what I'm multiplying by each time. But we mentioned before that with these, like, where it tells you what it's losing. It's losing a fifth of its value. So losing would be decay, so 1 minus 1/5 in parentheses. What's 1 minus 1/5? No. If I have a pizza cut into 5 slices and I took away 1 slice, how many do I have left? 4/5. And you can even use your calculator for that. 1 minus 1/5 is 4/5. Guess what 4/5 is equal to? Of a decimal. 0.8. So that can be our equation. It looks like they want us to use t though for years. I mean, x is always time in exponential functions. In this case, it's time in years. And they did say like they want a value of the card C for 2 years after it's been released. I would put like C of t here. You might even be able to just put C equals 18,000 times 0.8 to the t, like not do the function notation. But like it needs an equation, so you have an equal sign. It needs to be something that when I plug in whatever time frame they want, so like in part 1, they wanted after 4 years. It needs to give me that value that we said. So 18,000 times 0.8, and put this all in the calculator at once, because technically you should be doing exponents first. And I do get the 7,372.8. Like I do get that. So we problem solved our way through it here, although I do see a lot of people make mistakes when they problem solve it this way. Because they forget that when time starts it's 0, the design is shown out, and then it's like continuing pattern. This, if you could just remember how to make the equations, is a lot easier. We have to identify initial amount, either what it's gaining or losing each time, or what it's multiplying by each time. And then X is always. Questions on that? Okay, any other questions from your review? Okay, so use a diagram to show that this expression is equivalent to this expression. So that unit was about what? Unit 6? Or even just reading, like even just looking at the expressions, what function does that unit go with? So, graphing what type of function specifically? So like I said, there's three major types of functions. There's linear, exponential, and so this is quadratic function. And specifically a lot of like the graphing and converting it to different forms. Unit 7 was mostly like solving them algebraically. So keep that in mind. Like you should recognize this as a standard form of a quadratic and this as the factored form. If we want to show that they're equivalent, and then it also says like use a diagram, they want you to recreate those area models. We did that a few different times in the notes. Like show that they're equivalent. This is what they want you to do. If you show that they're equivalent another way, which I've seen students try, I mean, I think I did give them some points, but like what I don't want to see is you guys drawing the picture of a graph. All right, that doesn't really sound like a diagram. This would be a diagram. So when I have two binomials multiplied together, my diagram would look something like this. You can put the plus signs if you want. Normally, if it's positive, you don't put the plus sign, but you can if you want. If it's negative, you especially need to put it because we don't assume it's negative unless there's a negative there. And then for each individual box, we are doing what? Multiplying. So that's why we call them an area model, because when you do the length times width, that gives you the area. So we're multiplying each time. And what else about that? You separate these based on the term. What is your first term? Here's second term. What's 5x times x? What is 2 times x? What is 5x times 3? And 3 times 2. And then typically here, before you write your answer in standard form, you check to see if there's any like terms. Does the 5x squared have a like term? And I start with that because typically we want like it to go in this descending order. All right, so the 5x squared doesn't have a like term. Does this x term have a like term? All right, so the other x to the first power. We combine them. Combine means add. When we add things that are like terms, we're really just combining the coefficients. So what's 15 plus 2? And it's a positive 17, so I'm going to put a plus. And then when you combine like terms, the variable doesn't change. When you multiply, you apply those rules like x times x is x squared. When you're adding, it doesn't change the variable. This changes the number in front. All right, and then lastly, this 6 doesn't have a like term. It's all that's left. It's positive, so we can put plus 6. And because this and this are the same, that is how you can show that they're equivalent. Now for the next part is this expression equivalent to that one. Explain or show your reasoning. So please don't tell me in this first part, oh, they're not equivalent, because they are. And the second part, they could not be equivalent. You have to just like show it and justify whether or not you have to. So in this one, you have a few options. You don't have to do the area model, but since you had to do it for the first part, I thought you would say do that. Don't forget that you have to expand it. The exponent tells you to multiply the base by itself. So if you put that the answer is x squared plus 9, like it's not. The perfect squares, if you remember that lesson, always creates a trinomial. It should never create a binomial. So you need to remember to expand it like that first. And then you could FOIL, double distribute. I'm going to do the area model again since you have to do it for the first part. We have a 2-term by a 2-term for 2 by 2 blocks. X minus 3. X minus 50, and then multiply. So in this first box, what's x times x? In the second box, it says. In this one. And in this box, a positive 9. And then when you combine like terms, I get x squared, and already from there, I'm seeing that it's not going to create a 2x squared when I multiply, so your answer should be no. And you do have to say it. You can't just show me all your work and assume that I know what your answer is. You have to say no, and your reasoning can be this. Show me your work. But I get x squared. I have to combine like terms, negative 3x plus negative 3x is what? And then my other term that doesn't have a like term is a positive number. And you would say no, because it's equivalent to this expression down here. Questions on that one? Questions on others? I have time for one more. The first one on page 7. Okay, so I've been warning you guys that this one was coming, and it says you have to, first of all, it tells you what the solutions are. So you do not get any points for just telling me that x-intercepts are that and that, because it literally told you that they're that and that. You have to find the solutions by completing the square. So if you do a different method, I mean, if you don't know it by the final exam, which is tomorrow, you don't know it. But like at least I would get you some points than if you just left it completely blank. But completing the square has a very specific list of steps. What's the first step? Okay, good. Let me put these steps over here. So completing the square is the one that does not want the constant on the same side as the x terms. We want to move this to the other side. How do I move it? And whenever you go on one side of the equal sign, even just that step alone, they get you some points. Because that's one correct step then. So I get x squared minus x equals negative 5 over 36. What's the second step? And then what do you do? Okay, so we take half of b, we square it, and then we add to both sides. So what's my b value on this one? What is half of negative 1? Negative 1/2. And then we're going to square it. What's negative 1/2 times negative 1/2? Point what? Oh, 1/4. Which it is, and you can use a calculator for that. There's no reason that we should just stick this question to the fractions. You can use a calculator, type it just like this, and it'll tell you the right answer. It's 1/4. So we're adding 1/4 to each side. On the left side, it makes a perfect square trinomial. On the right, I do need to combine that. And I'm going to use my calculator for that, because why would I want to make my life harder by like trying to do it by hand? I would do in the calculator, parentheses, put your fraction in. Maybe it would help if I wrote it the correct fraction. Plus 1/4. Put that fraction in parentheses as well. Stop packing up. When I click this button, I can see the fraction, which honestly, I want the fraction. I don't want you to round it early because you will get the wrong answer in the end. So I get 1/9 on the right side. Because I do need to check your paper, so don't leave. Third step is to factor. And this is a perfect square. That's what completing the square means. It really should just be whatever half of b was. So when we did half of b, it was -1/2. It should be x minus 1/2 in parentheses squared equals 1/9. And then step 4 would be to solve for x. And then that would involve you undoing what's being done, what's opposite of squaring. Do that on both sides. You can use your calculator for that. You get plus or minus 1/3, I want to say, off the top of my head. Opposite of subtracting 1/2 is. Do that on both sides. And don't forget to solve for both cases. Anytime you square root, you have actually technically 2 answers. Go ahead and upload your work to Schoology, because I don't really have time to check every single person's paper right now. If you don't upload it, it'll be missing and it'll just be another deduction in your grade. So don't say I didn't tell you. But here's one of the answers that they said it'd be 5/6. And then the other one I get from doing the -1/3. There's the other one.